Hi, I'm Limani. Our project title is Improving Scan Document. Now I would like to present regarding problem background and objective of the project. With the development and popularization of technology, the ability to scan document has become a necessary skill for a people. People often scan document into a computer. For example, students often scan their homework to their lecturer. Or people often scan important contracts to their client, especially during this pandemic. Although scanning document is very convenient, but scanned document usually have a common problem, which is the word of the document is very blurry. One of the reasons cause blurry image is camera shake. It will produce an overlapping or blur image. When the image is magnified and observed, a subtle camera shake may produce a large amount of blur. Another reason of causing overexposed problem, which is people usually scan the document with higher ISO. Overexposed scan documents are too bright and have very little details in their highlight and unable to read the contents of scanned document properly. Moreover, document image may be contaminated with noise during transmissions, scanning, or conversion to digital form. I give you an example. Every single lecturer must map their problem with which like they will receive an answer paper from student very blurred until cannot be read. Or I give you another example like people who are receiving the scanned document from the director of the company, but the document is not clear at all and he is not there to ask him to rescan it again. How to solve this problem? Thus, in response to this problem, our group analyzed and produced a program to enhance the scanned document. I give you some proof about the issue of scanned document. We can see that this document is blurry and it has a quite high exposure. This photo is shown here without processed by MATLAB. Next, in this image, we can see that there are a little bit of noise. Let's move on to the objective. We only have two objectives in our project, which is to find out the technique needed in handling the overexposed, blurred, and noisy scanned document. Secondly, is to enhance and restore the document in order to see the document more clearer. That's all my part. Thank you.
Hi, I'm Corbin Xian and I'm going to explain about methodology. The left side shows the main flow chart for the program. Before it goes into the flow chart, it will simulate a distorted image. So first, the image is turned into grayscale intensity image because the color is not important in this document. Next, the problematic image is generated by blurring the image using Gaussian filtering, and then overexposing the image using this formula by adding a value into the image, and then add salt and pepper noise with noise density of 0.01 into the image. Noise density of 0.01 is used because the noise is not that serious with the advanced smartphone camera now. The process is repeated by replacing the 60 with 70 and 80 to create two more distorted images. So the main flow chart here, it will start with intensity transformation function using gamma transformation. Next, remove the noise and then sharpening the image. For the sub-module of intensity transformation function, gamma transformation was used to darken the intensity and improve the contrast. Calculating standard deviation of the pixel value in the transformed image is one of the ways to know the contrast of the image. The process will start with performing gamma transformation using the gamma value of gamma_1 and calculate gamma value and the standard deviation of the enhanced image was calculated, if the difference between the current standard deviation and the previous standard deviation is less than 0.5, then it will accept the previous gamma value as the optimum gamma value. If the difference is not less than 0.5, then it will increase the gamma by 0.5, then perform gamma transformation again until they found the difference is less than 0.5, and then accept it as the optimal gamma value. For the submodule of remove noise, it will use a square median filtering with the size of 3 × 3 to remove noise. After median filtering, it has smoothened the image a little bit, therefore the image needs to undergo sharpening process. The sharpening process here uses unsharp masking. Now I demo the program. This program uses 60 in creating the overexposed image. The result is 6 figures. The first figure shows the distorted image. Next is the result of gamma transformation. Next is the result of noise removal. Next is the result of sharpened image. And then the two graphs will be used in the analysis of gamma values.
Hi, I'm Rika here. I'm going to give explanations on the output that we got from the MATLAB coding. So let's start with this output, the first output that we got. The distorted image is generated by blurring the image using Gaussian filter, adding 70 to the pixel values, and adding salt and pepper noise with a noise density of 0.01. For the gamma transformation image here, the figure, we use the optimal gamma value, which is 11.5. Next, for the noise removal image here, okay, it was done by using median filtering, where the filter size used is 3 × 3. After that, the image was sharpened, and the results is shown in the figure with the title of sharpened image. The two graphs here was built based on the gamma value and the standard deviations in the process of gamma transformation. In the graph of standard deviation versus gamma value, it shows the standard deviations of the pixel values of the image where the image was undergone the gamma transformation with the respective gamma value. The last graph here of this output, which is D versus gamma value, shows the difference of standard deviations between the current image and the previous image, where the gamma value used has been increased in the current image gamma transformation from the previous used gamma value. Now let's move on to the next output explanation. Distorted image here is generated by blurring the image using Gaussian filter, adding 60 to the pixel values, and adding salt and pepper noise with a noise density of 0.01. We can see that the optimal gamma value is 11.5, where the difference of the standard deviation between the current and the previous enhanced images is less than 0.5. The standard deviation before and after gamma transformation is 20.7260 and 50.2971 respectively. The contrast of the image has improved. We can know the standard deviation value by seeing the graph of standard deviation versus gamma value at gamma value where the gamma value is 1 and 11.5. After gamma transformation, noise removal has been done on the image to remove salt and pepper noise. The result has been shown in the top right with the title of noise removal. We can see that after doing noise removal, there is some smoothing effects. The result of the sharpening is shown here in the bottom left with the title of sharpened image. The process result is much more better than the distorted image. However, it still has some disconnected lines. So as a conclusion, an optimal gamma value has been chosen based on the changes of standard deviation between the current enhanced image and the previous enhanced image. The advantages that we got from this program is that you can use this program to enhance the student script so that the lecturers do not need to ask students to send again the script after exam. That's all from us. Thank you.